All right, welcome everybody. This is the third talk of the first session of the second day of the iRODS User Group Meeting 2020. This is Sarah Roberts from CyVerse, and she's going to talk all about the discovery environment. Thanks, Sarah.
Hi. So what I'd like to cover in today's presentation is just a brief overview of the discovery environment. And then I'll talk about the web API that the DE uses to perform all of its tasks. We call it Terrain. And I'll touch briefly on our visual interactive computing environment. I didn't even bother to count the number of syllables. We just normally call it VICE. The first thing I'd like to cover is why we built this thing. When we first started this project, we quickly found that every creative endeavor has two basic types of tasks, right? You have the interesting tasks. You're creating new things. You're discovering relationships between disparate ideas. And then you have all of the stuff that you have to do to prepare to do those tasks. What we wanted to do was to take some of those mundane tasks and make them a little bit easier to manage. And we identified two areas that we thought we could help with: data management and software management. Everybody who has installed software knows that it can be a severe pain to keep all of your dependencies compatible with each other. And with the amount of data that scientists are trying to analyze, it can be a real hassle to try to shuffle that data around. And we also wanted to make the interesting tasks easier if possible. I'll touch on that a little bit more later. And finally, we wanted to make it reproducible so that if a scientist has a paper published, then somebody can go along, read that paper, find the link to the analysis, open the discovery environment, and rerun that exact same analysis if they want to. Before we could set upon our quest of making the lives of scientists easier, we had to satisfy a few requirements. The first was that we had to make sure that our system was scalable. We have to be able to handle the requests that it receives. We have to be able to handle the data that we're entrusted with. And we have to make sure that we can perform the analyses that are requested of us. And we also wanted to make it extensible so that users don't have to wait to install the computational software that they're going to run on their analyses. Instead, we wanted to make it so that they could install the tools themselves. The third requirement that we had was to make a low barrier of entry. A productivity tool doesn't really feel all that productive if you have to spend a few months learning how to use it before you can do anything useful. So we wanted to make sure that someone could get in, find the analysis they need, find the computational software they need to run, and run their analyses without having to spend an inordinate amount of time reading about our system. And finally, the entire reason that we created the discovery environment was to provide a high productivity environment for scientists to do their work in. These are some usage statistics. We did our best when we were compiling the statistics to exclude CyVerse staff because, let's face it, nobody really cares how many times we ran word count to test out the DE. Now, this is probably obvious, but the DE uses the CyVerse data store for doing all of its data management. And the data store is built on iRODS. And iRODS has a lot of helpful features that allow us to implement our system in a way that works for our users. First, we can share the data sets. This is something that's built into iRODS. We didn't have to do very much at all to implement that feature. Second, we used iRODS rules in conjunction with RabbitMQ and Elasticsearch to make the data in the CyVerse data store searchable. We also used RabbitMQ in conjunction with iRODS rules in order to set up a system by which we can automatically detect the format and type of data in files. Obviously, we can't detect every type of data and every type of format, but we can add new ones as we go along if we have to. We use the byte range retrieval features in iRODS to allow us to integrate with third-party genome browsers such as Ensemble and UCSC genome browser. And we also use the byte range services in the Jargon API to implement our internal tabular data view. And finally, we used iRODS rules in conjunction, or not iRODS rules, we used iRODS AVUs in conjunction with a Postgres database to implement our own structured metadata system. And this was a little bit before one was available in iRODS. Before I cover this slide in too much detail, I'd like to define a couple of terms. Within the DE, a tool is just a piece of software that you can run to perform a computational analysis. Some examples in the discovery environment are genome aligners and image analysis tools. An app is a definition that tells the DE how to launch a tool. So the DE uses an app to determine how to present the options to the user, and finally how to run the analysis once the job is submitted. The DE does have a graphical user interface to each app. This is different from the visual interactive computing environment that I was mentioning earlier. This is a graphical user interface that allows users to specify the parameters and the input files when they're submitting a job. We do have several different platforms available for execution. We have our internal HT Condor cluster. We have the high performance computing resources at the Texas Advanced Computing Center. We also can submit jobs to OSG and to our own Kubernetes cluster. We are adding support for Singularity in the near future. We do currently use Singularity in OSG, but that's the only system that we use it on. We're planning to expand that in the near future. As I mentioned before, users can add their own tools and apps. And our Vice analyses also have support, some limited support for GPUs. And we've got a couple of stats here. I'm not going to go into those in too much detail. Okay. Within the discovery environment, an analysis is just what happens when you launch an app. Basically, the job launches, the analysis runs on one of our compute platforms. When the job completes, an email will be sent back to the user and the output files will be uploaded. And I skipped over a couple of steps here. When the user selects an app, the interface will be displayed. The user can select the input files and the parameters. And then once the user clicks launch, the parameters are recorded and the job runs. And then the rest of the stuff that I just mentioned happens. We also have a batch processing feature, which allows users to select a list of files that they can submit once to a single analysis. And if there's, for example, 50 files in that list, we'll submit 50 different analyses so that they only have to go through the pain of entering the parameters once. This is our architecture diagram. As you can see, we do run in a Kubernetes cluster. Most of our microservices run in Kubernetes. We've got our DE web app. It's currently written in Java using the Google Web Toolkit. We're moving away from that, however, for a couple of different reasons. One is because we want to improve our user interface. Another is because GWT is no longer supported and we want to move away from it before it goes away completely. Our new front end will be written in React and JavaScript. We've got the Terrain API. It's a group of microservices written in Clojure, which runs on the JVM, and in Go. And then we've got our compute resources. I mentioned those before. And of course, the file system, which includes iRODS and search using Elasticsearch. We do use CAS for auth currently. We are exploring migrating to Keycloak because Keycloak provides a couple of features that we want to add. The most important being my mind just went completely blank. I apologize for that. The most important being integration with InCommon. No, not InCommon. I'm sorry, my mind just went completely blank. So, so for Terrain is our initial goals with Terrain were to avoid the monolith trap, right? So if you have this big chunk of wax software, then it gets a little bit difficult to maintain after a while. And if you need to rewrite a portion of it, then you often end up touching the entire ball of wax. We also wanted to be able to scale our certain components of the discovery environment separately if possible. So if one part of the system is overloaded, then we can scale up that part of the system without having to consume an inordinate amount of resources. We also wanted to provide a web API to our users so that they can extend and customize the DE if they want. If they wanted to run a script to submit jobs to the discovery environment, for example, they can do that. And the customization comes from of course, scripts that users can run, or even possibly even custom UIs instead of the discovery environment itself. We do have two sources of documentation. We've got our interactive documentation. This is based on Swagger, and that's available at the top URL. This is a work in progress. It's not complete yet, but it does provide an interactive console, which is very helpful. And the second set of documentation is available on GitHub, and it's mostly complete, although some pieces of the documentation are a little bit outdated. If you do visit the second URL, feel free to ignore the authentication instructions. The new authentication mechanism is much easier. So what I'd like to do next is a brief Terrain demo. And I'm going to go to the console first. So this is the Terrain console. And the first thing that I would like to show is the authorization process. It's a little cumbersome at this point, primarily because we were having trouble finding a way to streamline it, and we wanted to get the documentation done and revisit the authentication process later. So to authorize, what you can do is click on this authorize button in the left. The first step is to do basic authentication. So you enter your username and password here. Okay. Once you've entered your credentials, click authorize, and then the authorization header will be included in any request that's sent. The next step is to go down to this token endpoint. Oops. And click try it out. And if I've entered my password correctly, I should get a token back. And it's a miracle. I actually typed my password correctly on the first try. The next step is to take that token, go back to this authorize screen, log out with basic authentication, go back to authorize again, and then type in the word bearer here. Oops. Paste in the authentication token. And then as soon as you're done with that, you can actually do something useful. And luckily you only have to do that once every 8 hours, so it's not quite as bad as it seems. So if I click try it out, it will list the apps that are available to me. Okay, and I've just received the 2-minute warnings. So I was going to show a command line demo. It's basically the same. You can get the information about the terrain command line by looking at the Swagger documentation.
You have time for that. You have time for a demo if you want.
Do I? Okay, great.
Yeah, we've got 12 minutes total. We were just limiting to Q&A. Yeah.
Okay. Okay, so what I normally do to get my password is just do this so that I only have to type it in once. I've actually already done this, so I'm not going to do it again. But what I normally do on the command line is just run a command to set an authorization header environment variable. And if you don't enter the password and just enter your username here, curl will actually prompt you for your password. The chat window is getting in the way a little bit here. Just got to move it. Okay, I missed a quote somewhere. There it is. Assuming everything was correct, I should have my token, and I do. So what I would normally do to get, I'll say, a list of apps, and I'm going to search for my favorite app on the face of the planet, word count, just because I know how to use it. And the process, I find the process using the command line a little bit easier than using Swagger, but Swagger is really nice for the documentation. And I would go into more detail, but there's one more thing that I wanted to show, and well, two more things actually. First is our visual interactive computing environment. And I've got an app already running. Okay. I'm going to have to decrease the font size here because I think the, there it is. Okay. Now, this is an app, or this is a Jupyter notebook running inside the Discovery environment. And I'm actually going to use it to access terrain. So that's the interesting part. I've already run through this again once, but I can run it again. If you want to find this terrain intro, you can find it. It's at https://github.com/CyVerse/terrain notebook. And I think this powered by CyVerse link is broken at the moment. I'll try to fix it in the near future. But this does have an introduction to using terrain. It tells you how to search for words, or how to search for apps, sorry. It tells you specifically how to search for a word count app. And then it tells you how to launch an analysis. Okay, but I'm going to pull in the dependencies. This is our intro message. For anybody who's familiar with ZomboCom, this was taken pretty much verbatim from ZomboCom, so just a little inside joke there. Okay, it'll prompt for the username and password. Assuming I've typed that in correctly, you'll be able to get an access token. And judging from the amount of time that it took, I'm thinking it worked. Yeah. Okay, so this is just basically another way to do the same thing that I just did on the command line. And this does go into a little bit more detail and provides some detailed information about how we turn an app definition into a job submission. And finally, I would like to show our new improved user interface. This is a work in progress. We're not done yet. This is what we're calling Sonora, after the beautiful Sonoran Desert in which most of us live. Most of us on the CyVerse team, that is. Our new service does, our new API does, our new user interface, sorry, does use KeyCloak. So I can log in. And if I want to see my data, I can see the data in the data store here. And a list of apps that I have available to me. And any analyses that I've run, and it doesn't look like there's anything in here. Actually, I think that one's not quite implemented yet. And that's it for my demos. I actually skipped a couple of slides because I went straight into the demo. So I'm just going to skip over those. Well, maybe I won't. Okay, this is our Vice architecture diagram. One thing I would like to mention about this diagram is that it's at a different level of detail than the previous architecture diagram that I showed. These parts over here, these two blue parts, are essentially the architecture diagram that I showed you before, and then we go into more detail about how vice resources get created within Kubernetes. And on the right, we have a list of, or a description of what happens when a user tries to access a running analysis. Okay. And for the future, we're planning to integrate third-party storage providers, and looks like iRODS is going to make this really easy for us because they've got the S3 plugin. We haven't migrated to iRODS 4.2 yet. We're hoping to do so in the near future. The next thing that we'd like to do is to allow users to bring their own compute resources to the discovery environment so that we can submit jobs to their own compute resources on their behalf. And the improved user interface, I just showed a very brief demo of that. And Singularity support, which I spoke about earlier. And then we'd also like to be able to install our software on third-party resources. We've done this a few times. It's kind of a painful process. We're hoping to streamline that and make it available for general use in the relatively near future. And that's everything. Thank you.
Very good. Thank you, Sarah. That was live demos are always exciting, and at least from a technology standpoint, I'm glad it went pretty smoothly. I do have a question about the upgrade process that you're going to go through. How many iRODS machines need to be upgraded for that to be true?
Actually, I'm not sure what the number is. Tony will have a better number.
Is it 5 or 10? Is it 200? Is it? I mean,
I think it's probably on the order of 5 or 10.
Okay. Okay.
And maybe it's tens, it's not hundreds. So
right. Very good. John Constable from Sanger, he says, this might be a whole other talk, but how have they found Kubernetes? And in particular, how does that integrate with iRODS? We've got some users with custom Docker containers, but it's not clear how that exactly would work.
Yeah, we're not integrating Kubernetes directly with iRODS. We do have a container in iRODS, and we use Kubernetes secrets to store credentials, basically, so that we can retrieve the user's data on their behalf. We're using access rules to restrict the actual analysis container from accessing the iRODS credentials.
Right.
And that's worked out really well. The big win with Kubernetes for us has been running our own services in it, because it provides all of the coordination for us. We don't have to do that by ourselves anymore.
Right.
Which is a huge win.
With your own magic scripts, yes.
Yes.
I understand. Well, very good. Thank you so much, Sarah. That's great. And we can continue the conversation, of course, in the computer.
Sounds good.
Thanks a lot.
Thank you.